Hello everyone. In this video, we are going to deep dive into the methods for accurately estimating IBM-MAS OpenShift cluster sizing. We'll explore the key factors to consider, the tools you'll need, and the best practices to ensure you're getting the most out of your setup. Whether you are just getting started or looking to optimize your existing deployment, this tutorial has got you covered. Let's get into it. Understanding basics of OpenShift. So what you see here in this diagram is an OpenShift cluster architecture. And you can see that it's built upon your network, your compute resources, and your storage. And here in OpenShift, it's a typical OpenShift cluster where you have the control plane nodes, we have the infrastructure plane nodes, and the compute plane nodes. The infrastructure plane nodes is optional. If you like to move some of your infra ports into a dedicated nodes, we can use the infrastructure plane nodes. For this estimation purpose, I'm not including the infrastructure nodes. I'm just focusing on the control plane nodes and the compute plane nodes. So the control plane node is the brain of your cluster. Typically, it manages your port scheduling and everything that goes behind the OpenShift cluster is done by the master nodes or the control plane nodes. And the compute plane is the real workers. You can see we have multiple workers under this. So generally in control plane, we'll have 3 masters, and the compute plane, we have X number of worker nodes. So this is a typical configuration. I'm not deep diving into the OpenShift for this at this time. This is just purely for the estimation purpose. Here what we have to notice that each of these nodes highlighted here has its own CPUs, RAM, and hard disk associated. This is very critical. This is what you are trying to size up so that you can measure how many of the nodes that you need. For control plane nodes, typically we go by three nodes for redundancy purposes, right? So even if one of these nodes fails, the remaining 2 nodes can manage the cluster. So we go always, or it's recommended to use 3 master nodes in any deployment. If you are using cloud, it's advisable to use multiple zones, so that you don't keep them in same data center. So that's a typical architecture. Compute plane nodes, similarly, like you try to split them. Similarly, you try to put them into different availability zones in the cloud space. If it's an on-prem, you try to put in different servers or even different racks. Another important concept for this estimation purpose you have to understand is the pods and containers. This is the core of the OpenShift. The container is where your application is running. The pod is the actual wrapper around your container. So container, as I mentioned, like typically it's your application. In case of Maximo application suite, you have multiple containers. MongoDB is a container, MAS core is a container, manage is a container. So container is packaged and imaged with its software required library softwares and its dependencies. But you have to remember, container also virtualize the operating system within itself. So to run what is required for to run the application, it has everything managed within that container. But the container itself cannot be executed, or I cannot place a container within a node. So that's where the pods comes into picture. Pod is a kind of a wrapper around the container, and a pod can have 1 or more containers. Generally, we see 1 container per pod. So what pod does? Pod is just provides a shared resources such as volumes and IP addresses. The IP address is important. So the OpenShift creates its own OVN or its own networking, and that's how the infrastructure or the ingress controller balances the load balance between different ports. So typically in a cluster, there will be a number of ports runs. In MAS, if you look at, there are 250 plus ports that's running, and the load balancing between this port is managed by the OpenShift. So if take an example, if a MAS core request comes into the load balancer, load balancer will forward that request to the ingress controller. Ingress controller then understand which of the pods actually can serve this request, and that traffic it is routed to the pods. And within the pod, the container will be responding for that request. So that's a typical architecture for a OpenShift. So we talked about the master node, worker node, pods and containers. We typically try to size based on the requirement of how many pods you want to run in a worker node. Right? Normally, these pods are like the customer application pods are executed or run in worker nodes. So I can fit multiple pods into single worker node uh, depending upon the availability of RAM and CPU core, right? So if my pod requires one core and 8 GB of RAM, if I have this node 1 GB and 8 core of RAM, 8 core of CPU, then I can run only one pod here. But typically a pod doesn't require that much resources. It may be half of a core or maybe 2 to 3 GB of RAM per pod, but it depends, right? If it is idle, it may you see that it's not even using any CPU. But if the container is heavily processing something, you will see a spike in the CPU usage. So you have to, when you estimate the OpenShift cluster sizing, you are actually estimating the number of worker nodes, right? So depending upon the RAM CPU, we need to do a calculation where you typically try to understand how many ports you can fit into a worker node. So what you see here in the top section, you can see we have the estimating factors and then have some formulas and one example in the bottom. So the estimating factors, if you see, like the main input that we consider is the required user concurrency. This is not the concurrency I'm talking about in the app point, suppose that you are allocating. Yes, that is a concurrent users, but that doesn't mean all the concurrent users are concurrently interacting with the system. So we have from those concurrent plus authorized users from the Maximo MAS core, how you manage the end users into authorized and concurrent users, you have to kind of estimate how many concurrent users really hitting the system, right? So if you have, take an example, if you have 500 or 1000 concurrent users, that doesn't mean even the 1000 users logged in, it's hitting the system. Of course, the app points are consumed. I'm not talking about the app points. I'm talking about the user load on the system. So it's purely depending on each user hitting the server as a request URL or API or whatever, right? So that's exactly what we are meaning by concurrent users when you estimate the size of the your cluster, right? It's never go by the actual whatever you allocated on your MAS core concurrent app points. If you want, you can go with that, but I will say that will be kind of over provisioning. There is like less chance of all the users hitting at the server at the same time. But it's up to you how you want to handle that. If you want to go full concurrent, but what I've done here is 50% of the concurrent users in my app point. So here you can see like 500 users have used, but actually my concurrent app points is close to 700 and 800. Right? So that's a required concurrency. Then cluster strategy. Another important input parameter for the calculation of the cluster strategy. In OpenShift, you can have single cluster and dedicated MAS core, but you can have single cluster hosting more than one MAS application, MAS cores, right? MAS and MAS core applications. So if you are going with multiple workspaces, multiple MAS application, yes, of course, you have to calculate the cluster size accordingly. In this example, I am considering a dedicated cluster with dedicated MAS core, one to one configuration. The pod strategy, I already talked about pod. The pod requires storage, the pod requires RAM, the pod requires cores. The pod consumes cores, RAM, and storage. Okay? So you have to understand each pod how much is gonna use. So in this example, if you look at this section, we have the number of UI ports. How I calculated that is concurrent user load divided by 45. So this number means each UI port can serve up to 45 users. So generally it's between 45 and 50. 50 is the maximum, 45 is kind of moderate value that you can use. So if you divide it by concurrent user load by 45, you will get the number of UI ports required. Right? Similarly, you can use calculations to estimate number of MIA ports, the MEA, and the cron and report. Right? So in this example, you can see I used our MEA as maximum requested ports as the only one port running. We have the cron one port running, report one port running, and this calculated number of UI ports, which is the most end user the component, right, is 50. I use 50. I assume that one port can serve up to 50 users. So divided by 50, I get total 10 users. But you can be a little bit moderate and say 45 or 40 if you want to a little bit adjust that value. So I have total 14 ports calculated, right? Now in the top section, what I made a decision, my cluster worker node will be of 32 GB RAM and 12 core, right? I can go for 128 GB RAM and 24 core or something, right? But in OpenShift, instead of vertically scaling, that means using high-end machine with less number of worker nodes, it's ideal to horizontally scale. That means smaller number of configurable worker nodes and multiple and expand them, scale them as we go, right? So here I just picked 32 RAM and 12 core. You can go up to 24 and 8 core is minimum, right? You require. Because Mongo, our manage requires almost 3 to 4 core, so you will be able to only fit one pod in that worker node. But in this example, if you have one worker node, I have 32 RAM, GB RAM. So maybe 20-30% of it's gone, right? It's used by the operating system and other component. So remaining is available for the OpenShift cluster and port scheduling. So based on this, now I'm going to calculate the estimated required total memory, right? Total memory is calculated based on this formula here. This is a 7 is a constant that I assume, and this is a limit per pod, right? You can, it's a variable, right? I just put a constant 7. You can give up to 6 or 10, but there is a limit in the OpenShift where you said saying that a pod can request only up to 7 gig or 6 gig of RAM. That limit you can set. By default it is set. This is to avoid any pod, rogue pod running and consuming a lot of memory. Similarly, we have the core we can set, but in this example I'm not taking one core, I'm just taking 0.8 core. Usually it's only between 0.4 and 0.8 is in mass I have seen. So if you multiply that, you just add additional 4 cores for other stuffs, so you get both values. So I have the memory and the CPU core. So in this example, I have 91 total 91 GB required for the cluster and 14 GB, 14 cores to run these many ports. Right? So if you now how to calculate the number of worker nodes. So we have, this is our input parameters for the worker configuration. So estimated worker node is equal to this estimated total memory divided by the available memory, and that will give you the four cores. If you round it, it's around four worker nodes. So this gives you 4 worker nodes to fit 14 ports. You don't have to worry about how you're going to fit in these 4 nodes. So that's where the OpenShift comes, right? Based on its memory and storage and core availability, the ports will be scheduled. The problem happens, suppose when a memory is not available, a disk storage is not available. That is where the memory pressure or disk pressure happens and the port gets evicted from a worker node. Even though it's evicted from the worker node, it may get scheduled in another worker node where it is available memory. Right? If there is no available memory in any of the worker node, then we have a problem, right? Because the condition where we say the number of ports requirement is not met, then the cluster will be in a degraded state. So to avoid that, you need to make sure the calculation is right. You need to manage your port. You don't spawn too many ports, right? So here we have 14, right? So this is the maximum it can handle. But in OpenShift, you can go click and make this is 15 ports. Now we have a problem. There is scheduling issue will happen. To avoid that, what you have to do is add additional worker node of the same configuration and recalculate and see how many ports you can fit into that. Right? Based on these two formulas, you can easily figure out, right, how much a port is going to take. And once, if you have a OpenShift and MAS configured in your environment, take a look at how much each of the ports using, how many RAM it's using, how many core memory it's using, and you use that intelligence to optimize your cluster back. Maybe you are over provisioned your cluster currently, right? You may have 10 worker nodes sitting out there, which is kind of waste of money and waste of resources. So better you keep monitor all these variables what I mentioned above, and try to optimize your cluster to be a really healthy state. And of course, right, if there is a spike happens, you can always add worker node and scale up, right? Scale down and scale up. So make use of the elastic nature of OpenShift clusters, and that will save you a lot of money in the long run. Now regarding the storage, the disk storage required for each worker node. For MAS, we can allocate close to 250 to 300 gig per worker node. That is a safest bet I can recommend. If you store less, if you don't have enough disk storage, you will again see a disk pressure and other related issues on the cluster. So make sure you have enough good IOPS, SSD based hard disk attached to your worker node for performance. Because each of the port read write to these worker nodes, these hard disks, so important to have the required amount of storage available to them. And finally, a couple of infrastructure size best practices. There are a few high-level key points I want to highlight. One is the OpenShift is elastic. Make use of scaling up and scaling down strategies to optimize the cost. So you might have initially provisioned a cluster, which maybe you might have over provision. So as I mentioned, look at the behavior of your cluster, monitor for a couple of weeks or months, and learn from that to optimize. Use the same calculation and to optimize your number of worker nodes and saves cost in the cloud world. If on-prem, avoid over-provisioning and under-provisioning. Cloud is on-prem is a little bit tricky because you need to have the availability, right? There is a chance you are over-provisioning or under-provisioning. But if you properly calculate, you can get close to a optimal range, but make sure there is an available capacity to scale up. Right, in on-prem cloud, it's not problem. You can add worker node and just on the fly add remove. Yeah. On-prem, you need to size it up and make sure you have available compute capacity to scale if needed. Monitor user trends and optimize the cluster. As I mentioned, it's not a one-time job, right? You need to keep monitoring. The users may come, the users may get deactivated. A lot of activities happening in the platform. So based on trend is always, as an administrator, you need to make sure you optimize a cluster. Monitor your worker node and ports capacity usage and trend. Another option I told you, right? Since it's a COTS product, they behave same, right? You can see that whatever IBM code base they used will be standard across the clusters. But if you are using your own application, right? If you release a new version of it, you need to make sure the port is not consuming more cores and more memory. Same with IBM. As the new version comes up, take a look at whether the port is started consuming a little bit more memory and core. Then you have to scale your cluster. Maybe MAS 8.11, maybe using 0.8 core and the 3 gig of RAM maximum. Right? But as you go to MAS 9, it may be using 1 core in a steady state. So you need to keep look at the trend, look at the changes coming in, upgrades and stuff, and always try to optimize your cluster. So that's all about the estimating factors, how you can estimate your cluster size. This is a different approach, but IBM has a mass calculator which you can use. I think it behind the scenes you're doing the same thing, a little bit a minified version of it. But I just want to give you an overview how this is being calculated and what are the impacts and best practices. I really hope it helped you all. Thank you.